Application of derivative. First question. A small cuboid box has a rectangular base of length 3x, width x, and where x is greater than 0. The height is y centimeter where y is greater than 0. So you can see this is the length, this is the width, and this is height, which is given 3x, x, and y respectively. This is a non-calculator question. The sum of the length, width, and height is 12. Write down an expression of y in terms of x. They are asking to write down y in terms of x. So sum of length, width, and height is 12. So length is 3x, width is x, and height is y. So 3x plus x plus y is equal to 12. 3x plus x is 4x plus y is equal to 12. They want y in terms of x. So y isolate. So y keep it over here. Take 4x on the other side, becomes negative 4x. So 12 minus 4x is your first answer, which is for 1 mark. Now they are introducing another variable, which is v. The volume of the box v is v centimeter. The volume of the box is v centimeter cube. Find an expression for v in terms of x. Volume of box or cube or cuboid is length into width into height. So 3x into x times y, which is v is equal to 3x times x times y, which is 3x square times y. We cannot solve any equation with 3 variables. So you have to convert either x or y in terms of new variable because your v is fixed. In the previous part, we found out y. So we have to use this y from this in this part. So v is equal to 3x times x is 3x square, and y I am writing in a bracket because it has 2 terms. So 12 minus 4x. Never keep it like this. You have to simplify always. So v is equal to 3x square times 12 is 36x square, and 3x square times negative 4x is 12x cube. So 36x square minus 12x cube is your final volume expression. Third part, as it's the application of derivative, so for sure they will ask you to find out the derivative. So dv upon dx. So we will write out the actual expression of v we found out in the b part. V is equal to 36x square minus 12x cube. Take the derivative of v with respect to x. 36 will remain as it is. Derivative of x square is 2x. 2x into 36 is 72x. Negative sign as it is. 12 will remain as it is. Derivative of x cube is 3x square. 3x square into 12 is 36x square. So you got your final dv upon dx expression is 72x minus 36x square. Both terms are correct, so then you are getting 2 marks. Find the value for which v is maximum. Whenever you read a word like a maximum, minimum, then always you take a single derivative to 0. Because you are aware about that when you have a curve and maxima, minima, that means slope at that maximum point and minimum point is horizontal. Or line at that of tangent at maxima and minima is horizontal. That means slope is 0. Slope means dv over dx, that is equal to 0. We already found out dv over dx is 72x minus 36x square equate to 0. Now, always take common because this is a quadratic equation, so you have to justify your 2x values. I can see between these terms, I can see 36x common. If I'll do 36x common, 72x over 36x is 2. Negative sign as it is. 36x square divided by 36x is x. That means product of 36x times 2 minus x is equal to 0. So 36x is equal to 0, which is x is equal to 0, which is not possible because your length or width cannot be 0. And second, 2 minus x is equal to 0, so x is equal to 2. If this becomes a negative, if this is coming as a negative, that is also not possible because you are doing application where real life the length cannot be negative. So your final expression right now here it is a positive, so x is equal to 2. So find the value which is x is equal to 2. Next, justify your answer. Now there are 2 methods. One is a double derivative and one by using a sign change. using this first derivative. I'm explaining first double derivative method. First double derivative method, to show that v is a maxima at x is equal to 2, find second derivative. Second derivative, so we will first write down dv over dx is 72x minus 36x square, which we found out in the previous part. Take derivative of this, so dv over dx bracket derivative is d square v over dx square. 72x, 72 as it is, derivative of x is 1, so 72 into 1 is 72. Minus 36 as it is, derivative of x square is 2x, 2x into 36 is 72x. Now you have to substitute that single derivative value where you are getting a maxima or minima, which is x equal to 2, in this double derivative. So I am substituting 72 as it is, 72 times 2, because x value is 2. I am getting negative 72. If double derivative is less than 0, then that value is maxima. If double derivative is greater than 0, then that value is minima. This is one method, or I can use another method by using a single derivative. Single derivative, for that purpose you need to see this diagram. This is a maximum point. At maxima you are getting a slope 0. That is why we got x is equal to 2. Before maxima, if I'll take a tangent, the slope is positive. And if I'll take a tangent after maxima, the slope is negative. When I say slope means what? Single derivative. So pick up any point before x is equal to 2 and you check that by substituting in single derivative if the slope is positive. And after x is equal to 2, if you will get x is slope is negative, then you can say that at x is equal to 2 it is a positive. It's a maximum. So we will use first derivative test. dv over dx is 72x minus 36x square. We got two solution, x is not equal to 0, x is equal to 2. Obviously this is not coming, x is equal to 2 is coming. So I am making one line here and I am writing in between 2. That is the value which we got. Take any one value before 2. Take any value before x is equal to 2. Let's say x is equal to 1 and substitute that in your single derivative. So if I am substituting single derivative, 72 into 1 minus 36 into 1 square, I am getting 36, which is positive. That means my slope is positive. Now take any value after x is equal to 2, which is x is equal to 3, and substitute that again in this equation. 72 times 3 minus 36 times 3 square, I am getting negative. That means my slope after x is equal to 2 is down. So you can see before x is equal to 2, slope is positive. After x is equal to 2, slope is negative. And at x is equal to 2, slope is 0. Therefore, we can say that v is a maxima at x is equal to 2. You can use any method, you will get the full marks. Last part, find the maximum value. So maximum volume, so we have to use actual volume equation, which is 36x square minus 12x cube, which we found out in the second part. We got x is equal to 2, substitute that x is equal to 2. So 36 times 2 square minus 12 times 2 cube. 36 times 4 minus 12 into 8. 144 minus 96 is 48. As it is an application problem, you please write down the units properly. So volume is equal to 48 centimeter cube, which is the maximum volume we can obtain from the given from given dimension. Thank you.